So our next example on hyperbolas tells us that an airplane crashed and was heard by a park ranger and a family camping in the park. The park ranger and the family are a quarter of a mile apart, and the ranger heard the crash 1 second before the family. The speed of sound in the air is approximately that per second, 1,100 feet per second. Describe a possible path of the plane crash. So what happens here? This is what we're going to come back to, but let me kind of talk you through a few things. Oh no, hang on, sorry. Okay, so basically what's happening here is that the park ranger and the family, okay, those are dots, pretend. One of them is a park ranger, the ranger, and the other one is this family, and they're a quarter of a mile apart. Okay, and they hear a crash. They hear this. There's a plane that crashes, but the park ranger hears it 1 second before the family. So, so if you remember, well, so here's a hyperbola. If the crash is somewhere over here, then the sound is going to travel both to the ranger and it's going to travel to the family, but it gets to the ranger first. And so they're asking us to describe a possible path of the plane crash. So the plane crash is going to be somewhere on this hyperbola, and I'm going to go to the next slide and kind of talk through why it works that we can use a hyperbola. Okay, so if you remember, whenever I have a hyperbola, it looks roughly something like this. The distance from any point to a focus, and then the distance from another focus. Okay, hang on, let me try this again. Let's call this D1, and let's call this D2. What happens here is that no matter where this point right here moves, D1 minus D2 is always constant. Okay, so let's think about this for a second. So say I'm sitting, here's a focus, there's the other focus. Say I'm at this point, I'm at that one of the vertices. Well, then you'll notice the distance from here is this little blue line, and then the distance to the other one is this red line. Well, so what we know is that the red minus the blue is always constant, or you take the absolute value, whatever, something like that. So when we think about in our hyperbola, if this is the center, HK, then we've moved okay, we're going to assume that this is x minus h squared over a squared minus y minus k squared over b squared equals 1. Excuse me. Okay, so then what we've done here is to get to the vertex here, we have moved a units. Well, and then to get all the way to the focus, this entire distance from here to here, that has moved c units. And we went up b. Well, keep in mind c squared is equal to a squared plus b squared. Okay, so if we look at this little piece right here is the same as this distance right here. Well, so this entire thing now here becomes 2a, and this entire thing here is 2c. Okay, so we know this distance, man, my colors, this distance through here, nope, that's not my point, hang on. Okay, sorry, I figured it out. So what's happening here, let me create a new slide. If we've got a focus and a focus, and say the crash happens right here. Well, the sound takes a certain amount of time to get here as it goes, from the crash to this first focus. Well, the other, yay for the bells. Okay, the other path, it's going like this all the way to the other focus. Well, from here, this distance is the exact same, this little piece is the exact same right here. So the difference in time is going to indicate how wide this is right here. So when we come back and look at this particular problem, it tells us, okay, here's our situation. Here's our park ranger, here's our family. It tells us the park ranger and his family are a quarter of a mile apart. So we need to figure out how many feet that is. So it's a quarter of 5,280 feet. That's 1 mile. And then it tells us that the ranger heard the crash 1 second before the family. Okay, so in that 1 second, it went 1,100 feet. And so this distance through here is 1,100. This entire distance is a quarter of 5,280, which we'll figure that out in a second. Okay, so since the total distance is a quarter of a mile apart from them, that means they're 1,320 feet apart. And so then that tells us that the distance from the center all the way to here is half of that, which would be 660 feet. And then so C is equal to 660, and A is equal to half of this. Oh, I labeled that badly. That was 1,100. It's half of that, which is 550. Okay, and then we can use the equation to find C squared equals A squared plus B squared. So 660 squared minus 550 squared is going to be equal to our B squared. Sorry for the mess. So our B squared is equal to 133,100. Our A squared, oh, I should have found that a second ago. Our A squared is 302,500. So our final answer, I just assumed that the center was at the origin because it makes life easy. And I said that it was x squared over 302,500 minus y squared over 133,100 is equal to 1.